students, welcome to Legacy IAS Academy. In today's video, we are going to discuss about a recent activity event that has happened in Turkey, currently known as Turkey. So, as we know that earthquake has struck Turkey and also the nearby region of Syria. So, in this video, we are also going to discuss not only the news related to Turkey, but also we are going to discuss the types of earthquake that we encounter on the earth, the causes, the main causes that result into the earthquake, and also how we measure the intensity, magnitude, and overall damage that can occur due to the earthquake. But before moving to that, let us try to understand that what actually has happened in Turkey. So Turkey, today called as Turkey, has been hit by a series of powerful earthquakes since yesterday, and what we can say is early hours of Monday. And the first earthquake was of very high magnitude, somewhere about 7.8 on the moment magnitude scale, and it has been described as the strongest earthquake that country has experienced in over a century. The last similar kind of earthquake Turkey has experienced somewhere in year 1900. And after that, almost 41 other earthquake of magnitude 4 or higher, and many of these are also aftershocks, have been recorded in the same area, that we can say the southeastern part of Turkey, which also has border with the neighboring region of Syria, as far as the statement given by the United States Geological Survey is concerned. Taking this into account, as the Turkey is facing a massive destruction and disaster due to this earthquake, Government of India has dispatched its National Disaster Response Force search and rescue teams, and along with it, they also have seen trained dog squads, medical supplies, drilling machines, and other equipment which can be helpful for disaster response in the case of earthquake in Turkey. So let us first try to understand that what exactly is earthquake, how can we define it. So as you know, earthquake is when we feel a kind of tremors or we feel a kind of quake or tremor. It is when the earth's surface seems to be shaking, and the shaking of the surface of earth mainly result due to the sudden burst or sudden release of energy in the lithospheric region of the earth, that is the solid most upper part of the earth. And due to this disturbance, seismic waves are generated which carries the energy and then transmits it up to the surface. One other interesting term that we might have come across is aftershock. That means once the major earthquake hit Turkey, after that several aftershocks after that has been recorded here. So aftershocks are something that is considered to be a sequence of earthquake, albeit of lower magnitude, that happen after the larger main shock on a fault. Now, fault is a region where actually we see disturbance or break in the rocks of lithospheric slab of the crust. An aftershock occurred near the fault zone, where basically due to the reason of main shock, rupture has occurred, and many times also due to the break in the rocks, again the earth's crust, lithospheric slab, the plates of the earth, they try to readjust themselves, and as a result of this readjustment process, also many aftershocks are generated which are encountered on the earth's surface. So the question comes that where exactly in the Turkey this earthquake has hit. So we have one term related to earthquake that is known as epicenter. Epicenter is the point directly above the hypocenter, and epicenter is the first place on the earth's surface, above the earth's surface, where the earthquake is or seismic waves actually reaches. So as we can see, this is the map of Turkey, and as we can see, this is the Syria, bordering region of Syria. So Gaziantep is the place where the epicenter of the what you can say strongest earthquake has been recorded. And as you can see, as we are moving away from the central area, the color are becoming lighter. That means the intensity or the damage caused by earthquake also reduces. That means the maximum damage destruction due to the earthquake can occur near the epicenter, and as we move away from epicenter, the damage obviously will reduce. But overall, what we can see that a large part of southeastern Turkey and the northern region of Syria are impacted to some extent by the earthquake. And as per the recent report, more than 4,300 people have lost their lives as a direct result of this earthquake, mainly because they got trapped in the collapse of building, and many people have lost their life because for a longer period of time they were not able to evacuated and were trapped in the rubble of the debris. So before understanding the mechanism and the reason behind the Turkey earthquake, let us first try to understand some basic concepts about our Earth. So as we know, the Earth is totally divided into three parts. The upper part is called as the crust. Then we have the central part, middle part, that is called as mantle, and the innermost part of the Earth is called as core. So it is the crust region, that is a solid part of the crust, and upper solid part of mantle, that act like a single layer. And this single layer is then called as lithosphere, which generally extends up to the depth of 100 kilometers. Now, this lithosphere is not a single continuous layer, rather it is broken into different individual fragments, and each of these individual fragment of lithosphere is known as plate. And as we can see from this particular map, that the entire earth can be divided into multiple plates. The larger plates are referred as major plates, and within these major plates also have smaller plates which are called as minor plate. And as far as the Turkey is concerned, this is where the Turkey extends to, and the Turkey is also part of a minor plate which is called as Anatolian plate. Anatolian plate. So as we can see, we have South American plate, African plate, North American plate, Eurasian plate, African plate, and Philippine Pacific plate. These are the examples of major plate, while Caribbean, Cocos, Indian, Philippines, Anatolian, these are the example of minor plate. Now what happens is the plates are not always stagnant. They keeps moving with respect to each other. And this movement of plate can happen in two manners. Either the plates can move toward each other, or plates can move away from each other. However, there is one other type of movement that we see across the plate, along the plate, is that when the plates are neither moving toward each other nor moving away from each other, but rather they slide along a common boundary. And this is the example of plate interaction, which is called as transform plate interaction. As you can see from this particular diagram, this is our plate P1, this is our plate P2, and plate P1 and P2 are moving with respect to each other along this common boundary. So when these two plates are sliding along a common boundary, many times the rocks of this plate get stuck with each other, and the pressure keeps on building on these rocks. And suddenly, due to continuous movement of the plate, when suddenly the pressure is released due to the break in the rocks, this release of pressure creates generation of energy, and this energy is then carried by seismic waves up to the surface, which causes violent shaking of the earth's surface that results into the collapse and damage to the structure. Now, what kind of movement is happening along the Turkey? Let us try to understand it from this particular map. So as we can see, the two red lines, the upper red line is the one fault zone, that is where the two different plates, two different part of the lithospheric slab are moving along with respect to each other. Because on the northern side we have Eurasian plate, and this side we have the Anatolian. On the other hand, if you look at this southern red line, this is also representative of a transform plate boundary, where also we are seeing a relative motion between the Anatolian plate and the Arabian plate and African plate in the south. So basically, if you look at the structure of Turkey, both from the north and west and from the south and east, it is surrounded by two major fault zones, that is called as North Anatolian fault zone and the East Anatolian fault zone. And if you look at the epicenter, the first earthquake that happened yesterday of 7.8 magnitude, it occurred in the East Anatolian fault, and the second quake of 7.5 magnitude, that was another major shock, that occurred somewhere on the upper or the northern side of East Anatolian fault. That means what we can understand, that the major seismic disturbance, major tectonic disturbance that is going on, which is responsible for Turkey's earthquake, is occurring around the East Anatolian fault. Now let us try to understand this in more detail, that what exactly is happening. So as we have discussed slightly before, that the plates of earth are not steady, but they're continuously moving with respect to each other. And that is why this is the Anatolian plate on which Turkey currently is situated. So if you look across the Turkey, if you look around the Turkey, what we can see, that the Anatolian plate is surrounded by Eurasian plate, as we can see from the north, Arabian plate from the east, and African plate from the south. So what exactly is happening is that Arabian plate, as seen by this arrow, is continuously moving toward north. And due to this continuous northward movement of Arabian plate, the Anatolian plate is being pushed in the westward direction. And it is due to this push, Anatolian plate is having a movement which is with respect to both African plate and Eurasian plate in the westward direction. And it is due to this movement what we can understand, that it is sliding along the boundary on the northern side with respect to Eurasian plate, and it is sliding along the cone boundary on the eastern and southern side with respect to African plate and the Arabian plate. And it is due to the sliding of this Anatolian plate, what we can expect is that we have East Anatolian fault zone here, where earthquake of recent time of yesterday and today has happened, and then we have the northern Anatolian fault zone, which is the movement that is happening in Anatolian plate with respect to the Eurasian plate. So what we can say, that the transform plate interaction that is going on between Anatolian plate and Eurasian plate, and the Anatolian plate, Arabian plate, and African plate in the south, is responsible for several earthquakes that Turkey experiences. So as we are talking about, epicenter is a place which is situated just directly above the focus. Focus is also referred by other term of hypocenter. And simply, if we have to describe focus, it can be considered as that place below the Earth's surface where actual disturbance in the rocks of lithosphere has occurred, and which can also be considered as the origin point or the source point of the seismic waves. Now, if you look at the types of Turkey's earthquake, the focus of the Turkey's earthquake was situated somewhere about 17.9 kilometers below the surface. And on the basis of depth of focus, the earthquake can also be classified into three major types. The first type are called as shallow focus earthquake if the focus is situated less than 50 kilometers from the surface. Then we have the medium focus earthquake when focus is situated somewhere between 50 to 200 kilometers below the surface. And then we have the deep focus earthquake when the focus of the earthquake lies more than 200 kilometers or greater than 200 kilometers far below, deep below the ground surface. So as you can see, since the focus of the Turkey's earthquake was 17.89 kilometers, that means it can be characterized as a shallow focus earthquake. And since shallow focus earthquake is the disturbance is happening very closer to the earth's surface, what we can expect that the amount of the energy that is generated in the earthquake reaches to a significant extent up to the surface, and thus shallow focus earthquake are also considered as most disastrous in nature. Because obviously we try to compare it with deep focus earthquake. Deep focus earthquake, suppose it is happening at depth of 200 250 kilometers, by the time the seismic wave carries this energy to the surface of the earth, they would have lost a tremendous amount of the energy, and thus it will be least destructive. So it is also one reason what we can understand the destruction of the Turkish earthquake is very higher, because the focus is very closer to the surface. Now, as far as the characteristic of earthquake is concerned, it is basically measured on the two parameters. The first parameter is what we can refer as magnitude, and magnitude simply refers to the how big the waves are, because we know that seismic waves are the one that is carrying the energy due to the earthquake, and thus when you measure the height of the wave or the amplitude of the wave, that is when you get the magnitude of the earth. On the other hand, the energy that waves are carrying along with themselves is measured by something that is called as strength of the earthquake. So question comes that how do we measure the earthquake? So first of all, you talk about in year 1932, there is a scale that has been developed which is called as Richter scale. A Richter scale takes help of instrument that is called as seismograph. Richter scale is an example of logarithmic scale and measures the magnitude of the earthquake. And also to keep what we have to keep in mind that Richter scale is measured on a value of 0 to 10, and every unit increase that we see on the Richter scale represent 10-fold increase in the magnitude of the earthquake and 32 times increase in the energy released as a result of earthquake. However, later on it was discovered that Richter scale has lot of errors, and thus a much better scale was devised, which is today known as moment magnitude scale, represented by MW as a symbol. Like Richter scale, this scale is also logarithmic scale, but here the accuracy of moment magnitude scale is very higher, and it measures the moment. Now, what is the moment? So moment can be simply defined as a physical quantity that represents the slip that has happened around the fault zone, because as we have discussed, when two plates are moving with respect to each other, the two plates will slip with respect to each other. So what kind of slip we are observing around the fault zone multiplied by the entire area across which the slip has happened around the plate, that is what gives us the moment. And thus this moment magnitude scale measuring this value represents the total energy that is released in the earthquake event. However, understanding of magnitude is not only sufficient. Sometimes the other values or other measurement of earthquake, for example, intensity, is also very important to understand the damage. And intensity of the scale earthquake is measured by either modified Mercalli scale these days, or the older version of the scale was called as Rossi-Forel scale. So basically the modified Mercalli scale or Rossi-Forel scale measures the amount of shaking that we can experience due to the earthquake at any particular location. And this is very important because it is actually the amount of shaking that relates to the tangible impact, the tangible damage in terms of infrastructural damage, in terms of casualty, human casualty that earthquake will have. And as far as the intensity is concerned, on the modified Mercalli scale, it is measured between value of 1, where the shaking is not felt due to the earthquake, to value 12, where we have extreme violent shaking. And thus, if we try to compare the recent Turkish earthquake, it has been assigned a value of 9 on the modified Mercalli scale. That tells you that it is on a much more farther side of the scale, representing a huge damage, a catastrophic damage due to the result of this earthquake. So that is all about this particular video. I hope you understood about the concepts of earthquake, the causes, the types, and the measurement of the earthquake. If you like the video, please hit the like button, share it with your fellow aspirants, as well as subscribe to our channel for more such content. Thank you very much.